Hello, grade 7. Welcome back to our online class. In this video, we're going to talk about operations on integers. Integers are whole numbers plus the negative of counting numbers. Let's start with addition and subtraction of integers. Let's have your letter A, 5 plus 2. 5 plus 2 is 7, right? But let me add these two numbers using my chips. I have chips with positive and negative. Since 5 is positive, then I can represent this using 5 positive chips. And since 2 is also positive, I can represent this using 2 positive chips. How many chips do I have altogether? I have here 7 positive chips. Therefore, 5 plus 2 is equal to 7. Positive 7 or just 7. Letter B, 5 minus 2 is what number? I know that you already have your answer in mind, but again, let me discuss this using the chips. 5 minus 2 is the same as 5 plus negative 2. Recall the definition of subtraction. 5 here is positive, so I can use 5 positive chips. 2 is negative, so I can use 2 negative chips. Here's the thing. 1 positive chip and 1 negative chip will be canceled out. 1 positive chip and 1 negative chip will be canceled out. Then you count the remaining number of chips. We have here 1, 2, 3 positive chips. Therefore, 5 plus negative 2 is equal to positive 3. Okay? Letter C. Negative 5 plus 2 is what number? Is it 7, negative 7, 3, or negative 3? Let's see. The first number here is negative 5, so there should be 5 negative chips. The second number is positive 2, so there should be 2 positive chips. 1 negative and 1 positive will be canceled out. And then count the remaining number of chips. We have here 1, 2, 3 negative chips. Therefore, negative 5 plus 2 is negative 3. And for letter D, negative 5 minus 2 is the same as negative 5 plus negative 2. We always have to apply the definition of subtraction. The first number is negative 5. There should be 5 negative chips. The second number is negative 2. There should be 2 negative chips. We have nothing to cancel out here, so let's just count the number of negative chips altogether. We have 5, 6, 7. Therefore, negative 5 plus negative 2 is negative 7. We cannot always use chips in adding or subtracting integers, especially when we are already dealing larger numbers. So what we're going to do, we have to be able to come up with some rules. Based on these 4 examples, I can have rule number 1. When adding 2 numbers or 2 integers with the same sign, just add their absolute values and prefix the common sign. 5 and 2 have the same sign. Just add 5 and 2, which is 7, and just copy the sign, which is positive. Letter D, negative 5 and negative 2 have the same sign. Both of them are negative. So what you're going to do, just get their absolute values. The absolute value of negative 5 is just 5. The absolute value of negative 2 is just 2. 5 plus 2 is 7, and copy the sign. Copy the common sign, which is negative. So the answer is negative 7. Rule number 2, when adding 2 numbers or 2 integers with different signs, meaning one is positive, the other one is negative, subtract their absolute values and prefix the sign of the number with greater absolute value. Just like here in letter B, 5 is positive and 2 is negative. 5, negative 2, just get their absolute values. In other words, just ignore the sign. 5 and 2, get the difference. It's 3. What's the sign of the bigger number? It's positive. So the answer here is positive. Letter C, negative 5 and positive 2 have different signs, so we have to subtract their absolute values. The absolute value of negative 5 is 5. The absolute value of 2 is 2. What's the difference of 5 and 2? It's 3. And you take the sign of the bigger number. When I say bigger number, of the number with greater absolute value. In this case, it's negative. So the answer here is negative. Let's have more examples. This time, we're not going to use chips to add or subtract the numbers. Let's have letter A, negative 15 plus negative 12. Both numbers have the same sign. What do? You just add 15 and 12. That is 27. And you copy the common sign. The common sign is negative. Letter B, negative 10 plus 16. Negative 10 and 16 or positive 16 have different signs, so we have to get their difference. We have to subtract these numbers or the absolute values of these numbers. What's the difference between 16 and 10? It's 6. And what is the sign of the greater number? It's positive. So the answer is positive 6. Grade 7, when I say the sign of the greater number, I'm always referring to the sign of the number with greater absolute value. Okay, you have to understand that. Letter C, negative 6 minus negative 2. There are a lot of negatives here, but don't worry. We are going to remove some of them. So before we add or subtract these two numbers, let's try to simplify this first. Negative 6, negative of negative 2. Remember, opposite of negative 2 is positive 2, right? So we have here negative 6. This negative of negative 2 becomes positive 2. So nega, that is positive already. So we're just going to add negative 6 and positive 2. Both numbers have different signs, so we have to subtract their absolute values. 6 minus 2 is 3. What's the sign of the bigger number? Negative. So the final answer is negative 3. Letter D, we have here grouping symbols. Remember, when dealing with grouping symbols, we have to eliminate or remove the grouping symbols first. So we have to do this first. 4 plus negative 8. 4 and negative 8 have the different signs, so we have to subtract their absolute values. And the difference between 8 and 4 is 4. And then, what's the sign of the bigger number? It's negative. Then you copy here, negative 3 plus. Next, we are going to add negative 3 and negative 4. This time, both numbers have the same sign, so we're going to get the sum of their absolute values. The sum of 3 and 4 is 7. Just copy the common sign, which is negative. That's it. Next, let's have multiplication and division of integers. Before we tackle these examples, let's have the rules first. Rule number 3, the product or quotient. Product, by the way, is the result when you multiply two numbers. Quotient is the result when you divide two numbers. The product or quotient of two numbers with the same sign is always positive. And the product or quotient of two numbers with different signs is always negative. That's rule number 4. Take note of that. Letter A, negative 10 times negative 30. We are multiplying two numbers with the same sign according to rule number 3. The answer is positive. No need to write positive. 10 times 30 is 300. That's it. Letter B, negative 8 divided by 4. When dividing two numbers with different signs, the answer is always negative. Negative what? 2. Letter C, 5 times negative 12. 5 is positive, negative 12 is negative. We are multiplying two numbers with different signs. The answer is negative what? 12 times 5 is 60. And letter D, negative 51 divided by negative 17. We are dividing two numbers with the same sign. The answer is always positive. 51 divided by 17 is 3. By the way, if your answer here is like this, positive 3, it's still accepted. If the answer is positive, it's okay not to write the positive sign. But if the answer is negative, you must write the negative sign. Now let's have more examples. Letter A, negative 4 times negative 3 times 5 times negative 2. We are multiplying 4 integers here. Negative 4 times negative 3 is positive 12 times 5 times negative 2. 12 times 5 is 60 times negative 2. 60 times negative 2 is negative 120. Final answer. Letter B. For letter B, you have to recall the role of an exponent or the definition of an exponent. The base here is 3. It's not negative 3. It's different from negative 3 with parentheses. This is not the same as negative 3 with a square. Take note of that. The base here is 3. The exponent is 2. It means that we are going to multiply the base 3 to itself 2 times. So we have here negative 3 squared is equal to negative 3 times 3. We're just going to multiply the base 3 to itself 2 times. Negative 3 times 3 is negative 9 times. Negative 2 cubed, the base is negative 2. The exponent is 3. So we have here something like this. Negative 2 cubed is equal to negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is positive 4 times negative 2. The answer is negative 8. Take note of this. When the base is negative and the exponent is an odd number, the result is always negative. Negative 2 raised to 3. 3 is an odd number. The result is negative 8. Now we have here negative 9 times negative 8. It's positive 72. Letter C. For letter C, we have to deal with the exponent first before we do multiplication. This is negative 10 times negative 3 squared is the same as negative 3 times negative 3, and that is positive 9. So before I proceed, take note of this. When the base is negative and the exponent is an even number, the result is always positive. When the base is negative and the exponent is an even number, the result is always positive. We have here all over negative 5 times negative 2 is positive 10. Equals negative 10 times 9 is negative 90 over 10. You're dividing here two numbers with different signs. The final answer should be negative, and 90 divided by 10 is 9. You can apply the cancellation here before you divide or multiply the numbers. It's up to you. And letter D, 7 times 4 divided by 2 times negative 3 times 2 divided by negative 4. In this expression, we have a combination of multiplication and division. When these two operations are present in the same expression, then you always have to simplify the given expression from left going to the right. Whichever operation comes first, you have to deal with that first. Here, from left to right, 7 times 4 divided by 2, we have to do multiplication first because multiplication comes first. 7 times 4 is 28 divided by 2 times negative 3 times 2 divided by negative 4. Next, 28 divided by 2 is 14 times negative 3 times 2 divided by negative 4. Next, 14 times negative 3 is negative 42. We're multiplying two numbers with different signs. Times 2 divided by negative 4. And what's negative 42 negative 42 times 2? It's negative 84. The product is negative because both numbers have different signs divided by negative 4. Equals negative 84 divided by negative 4. Both numbers have the same sign, so the final answer should be positive. And 84 divided by 4 is 21. Okay. Let's have the order of operations. When we say order of operations, we're talking about the GEMDAS rule. When you were in grade 4 or grade 5 or grade 6, only MDAS rule was introduced to you. This time, we are going to add the grouping symbols and the exponents in that rule. That's why we have here GEMDAS rule. What do you mean by GEMDAS? G or E? G stands for the grouping symbols, grouping symbols. E stands for exponents. It means if an expression contains grouping symbols or exponents, then you have to deal with these things first. After that, that's the time you're going to proceed to multiplication or division, that's MD. And finally, addition or subtraction, that's AS. Let's apply the GEMDAS rule in the following examples. Letter A, negative 21 divided by 7 minus 2 times negative 8. Let's examine the given from left going to the right. We have here division, subtraction, and multiplication. And in this case, it's the division that is the most powerful. Yeah, that's the most powerful. So we have to perform division first. Negative 21 divided by 7 is negative 3. And we have here negative 2. I just would like to emphasize the multiplication here times negative 8. Between subtraction and multiplication, we have to perform the multiplication first. But before that, we have to apply the definition of subtraction here. So negative 3 minus 2 is the same as negative 3 plus negative 2. Whenever you encounter something like this, minus, always apply the definition of subtraction. Times negative 8. So this time I can multiply negative 2 and negative 8. Both numbers have the same sign, so the answer is positive 16. I'm just going to copy the rest of the terms here, negative 3 plus. And negative 3 plus 16, both numbers have different signs, so we're going to get or subtract their absolute values. What's the difference between 16 and 3? It's 13. And what's the sign of the bigger number? It's positive, so 13 is the final answer. Letter B. We have here quantity 8 plus 16 divided by 2 cubed minus 2 times 3. According to GEMDAS, we have to deal with grouping symbols or exponents first. There's a grouping symbol here, parenthesis, so we have to get rid of this parenthesis first. And in order to be able to get rid of the parenthesis here, we have to perform whatever operation is inside this grouping symbol. It's 8 plus 16. We will be forced to add 8 and 16. 8 plus 16 is 24. Divided by, we can now simplify 2 cubed because exponent is also very powerful. 2 cubed is 2 times 2 times 2, that's 8. Never multiply the exponent to its base. Most students answer this one as 6. No, it's not correct because 2 cubed is 2 times 2 times 2, and that is 8. Minus 2 times 3. From left to right, always read the given expression from left going to the right. 24 divided by 8 is 3 minus 2 times 3. We have minus 2 again. So we have to apply the definition of subtraction. This is plus negative 2 times 3. Multiply negative 2 and 3 first before you add. Negative 2 times 3 is negative 6. And finally, we have 3 plus negative 6. We're adding two numbers with different signs, so we have to subtract their absolute values. What's the difference between 6 and 3? It's 3. And what is the sign of the bigger number? It's negative. So the final answer is negative 3. That's it, grade 7. I hope you learned something from this video, and see you in our Zoom classes and in my next videos.